Welcome everyone to Data Analytics and Decision Making for a week 9 guest lecture with the CEO of Katonic.ai, Prem, and as well as Meghana, a data scientist at Katonic. So without further ado, today's title I'll let Prem discuss, but I think it's something along the lines of how to operationalize the business value of AI. And I think this is a very appropriate topic as we're now in week 9 of our course, where we've gone from the basics of introductory probability statistics to now building some of your own models in Python. And now the question is, once you've built the model, how do you actually deploy it and how do you operationalize it in your organization? So without further ado, I'll hand it over to Prem.
Thank you. Thanks, Lamont. It's indeed a pleasure for Katonic to be, part of such esteemed audience. I'm sure, all of you will be hearing this when you get time. So, Lamont has given me a challenge. The challenge is, to talk more about AI, not so much about building a model, because building a model is more of a commodity now. It's about the end-to-end process and how do you bring everything together to get the business value, right? In the end, if the AI is not solving a problem, or it's not increasing the revenue or decreasing the cost, it doesn't mean anything, just like any other technology. So with that, I have a small presentation. I'll run through the agenda. So Lemon, I think you'll have to let me share the deck. It says, once you do that, I'll share the deck.
How's that?
Let me try. Yep, it does. Okay, great. Let me share it. Okay, so let me know when you're able to see the presentation in full screen. Yeah,
looks good.
Awesome, thank you. So so Katonic, we just a quick intro about Katonic. So we specialize in operationalizing AI. Essentially, in order, if you want to take AI into production and get value, you have various stakeholders who need to come together. It's data scientists, data engineers, your business, your machine learning engineers, your DevOps engineers, and traditionally they all work in silos. We burst the silos, bring them all together, give them this collaborative platform where they can work together to take AI into production and get value, right? So today's agenda is very interesting. We're not going to be getting very technical into the model details. It's more about how to get value. So I'll do a quick intro about Katonic, a 2 minutes intro, so that you understand where me and Meghana come from. A bit of a context setting on what's happening in the industry. There's a lot of hype around AI. A lot of organizations want to use AI, but there's a bit of struggle. So I'm going to touch and talk a little more about those, the context, and also why AI is more challenging, right? I mean, in the last 10, 15 years, a lot of businesses have they've done digital transformation. They've spent billions of dollars. They've been successful. But, a lot of them are struggling with AI. So AI should have some unique challenges. So I'm going to quickly spend 5 minutes, talk about those challenges, because it's important to understand those challenges, because MLOps aims to solve those challenges, right? And once I've introduced what those challenges are, I'm going to deep dive a little bit into what MLOps itself is, right? Machine learning operations. I mean, it's a buzzword. We'll demystify that. I'll spend a few minutes there, and then talk about how an end-to-end MLOps process should look like. How do you really industrialize? How are Googles and Netflixes, Ubers of the world industrializing AI? What's the kind of blueprint or the process which they follow? And that's what I'm going to do. And then we'll jump into the customer churn model, where we're going to run you through a step-by-step process on how you can take data and then use that data to identify which customers are most likely to churn. So in this case, we'll take a imaginary bank called Data Bank, and we'll just run you through the end-to-end process. So that's on the agenda. Lemon, any comments on the agenda? You good?
This looks great, Prem. Yeah, let's just hit it off.
Awesome. So fantastic. So firstly, Katonic, we are a proud Aussie startup. We started 3 years back in 2020. And we are backed by some of the largest Australian fund, Artesian and Boab. It took us about 2 years to build the platform. We have 2 patents, but in a very short span of in 1 year, we've acquired a lot of big customers. A lot of them are outside Australia. I firmly believe that AI is going to be the future, and Australia should focus on being a net exporter rather than being importer in the next 10 years. And happy to be one of those companies who are going to contribute to the nation here. So so 10 plus customers, some big names here. We have technology partners and system integrators. And the good news is, we were recognized by Everest Group as one of the top MLOps platform. We are the only ones from Australia or APAC. Everyone else is from US or Israel. And this is fresh from the press, just happened last week. So we've been awarded from Frost & Sullivan, a very reputed brand name, as Entrepreneurial Company of the Year in the MLOps space. So that's a bit of, that shows we're doing all the right things. And thanks to, all of you for believing in Katonic. There's a lot of other awards we've received. Essentially keeps us motivated, and we feel that we're doing things in the right direction. So that was a quick snapshot of Katonic. Let's talk about what's a bit of a context setting. So like I said, a lot of organizations have done digital transformation. They've spent a lot of money, bringing all the data into one place. They've probably implemented BI, which is business intelligence, and they've started getting descriptive analytics. In fact, a lot of companies are still, working on that. 20 years back, it was easy. The data was in mainframe. It was in Oracle. It was probably in Postgres. But things have changed now. The data is all over the place. So a lot of organizations essentially are trying to do this, right? They want to move from, they've collected all this data and they want to get value out of that data. And everybody wants to be moving from descriptive to predictive. But more importantly, prescriptive, right? Prescriptive is where you are able to predict what is going to happen, and the AI also suggests you what actions you need to take to kind of improve yourself. But then the hard reality is that while everyone is trying to reach to that level, most of them are still stuck at the descriptive analytics, right? I've met more than 40 CIOs and CXOs in the last 3-4 months. I was traveling around the world, and most of them are still struggling with bringing all the data in one place. And definitely, that's an area where people are going to focus on. They're going to be, bringing all the data, starting to get value and move slowly towards the maturity curve. And it might take few years, few months, depending on the maturity. And organizations have realized that AI is key, and they've increased their investments. I have not met anyone who said we've cut our investments in AI. Most of the organizations have increased their investments, which is good. And the number of data scientists they've been hiring, it's so data scientist is so much in demand, right? But the ground reality is a little bit disturbing, right? So while 99% or 98% of the CXO level executives say, look, AI is great. We believe that AI is disruptive. It will give us competitive edge. Very few actually agree that they have the right capability, right? And capability doesn't mean just few data scientists, right? Because in order to operationalize AI, you need people, process, technology. Just hiring few data scientists doesn't mean that you're getting value. You need to have the process, the technology, the know-how, the focus on how to take data, understanding of the business objective and things like that. I'll touch a little more. And a lot of organizations are struggling, right? And meeting all these 30, 40 CXO level people, and I'm assuming there's lots here on the call. This is a summary of all the challenges which Katonic or MLOps solves, right? So some of the challenges which might resonate with you is we have a big data science team, but we hardly get any value, right? We have a lot of models in production, but the team is mostly maintaining them, right? And it's black box. We're not able to monitor. So the challenges are many. In the end, the solution is MLOps. So I'm going to talk about it. So having said that, what I want to do is I want to talk about why AI is hard, right? Because look, these organizations have spent a lot of time and money on digital transformation, right? And why is AI hard? So AI is hard because of multiple things. One, there's a perception issue, and there is certain unique challenges which AI brings in, right? So firstly, when we talk about AI, everyone thinks AI is all about building a model, right? So I've met a lot of, I myself have implemented a lot of use cases for many banks, right, as part of a large SI. And what I realized is that as soon as you talk about AI, it's all about building a model. So there's a team of data scientists who's brought in. They work together. Usually it's laptops or some kind of server which they get. They install all the dependency. They build a model. They spend a lot of time, and even when they come up with a project plan. 80% of the time and the money is allocated to model building, and then they assume that the model can be put into production. And so, look, these teams do a good job, right? There's a lot of work which goes into modeling, experimentation. The POC is successful. Everybody's excited, right? And when they try to move it into production, it fails, right? And it doesn't fail because the model wasn't good, right? Model was great. It fails because organizations struggle to integrate that model into the overall business process, right? So, for example, when you're operationalizing a particular model, the data, typically when you're given to a data scientist, it is a download from maybe a CRM system or an Oracle or a Postgres or a Salesforce or a SAP HANA. It could be anything, right? It's one thing to build a model with offline data, right? But when you actually productionize the data, productionize the model, you need to connect to that data, right? You need to pull the data, you need to do those transformations, you need to convert that model into an API, you need to have batch programs which can do inference, you need to monitor. There's so much which goes on, and there is so much of technology which is required to enable that, and there is so much of effort which goes in. Organizations don't they underestimate that effort. It's usually 80% to model building and 20% to operationalizing. It's the other way. And they end up overrunning the budgets, and most of these models become a museum piece, right? I myself have delivered many such museum pieces which are lying in many of the innovation labs, right? So that's the first problem, right? The perception is that AI is all about model building, model training. It's actually not. It's actually operationalizing. The second problem with data science is, the data scientists typically work in silo. They're given a laptop, they install their dependencies, they build a model. But when you're productionizing, they just give that code to the DevOps people. They have no clue what to do with it. They don't know how to operationalize it. The code which worked on their laptop might not work on the servers, the dependencies which they installed. So there's so much, the siloness creates a lot of problems, right? And MLOps, kind of tends to solve that. And the biggest problem is no proper handoff, right? That's the second challenge, in my opinion. And the third challenge is AI is unique, right? AI is not deterministic. So when I say deterministic, a mainframe code, I used to be a mainframe coder, right? I'm sure the code which I've written will still work. You give it an input, it gives you an output. Doesn't matter even after 20 years, because it's deterministic. But models are not like that, right? They are not deterministic. Models are function of code and data, and you need to train a model on data, right? And as the data changes, you actually have to retrain the model. And if you don't keep the model fresh, you might end up losing a lot of money. And I'm sure you would have heard of a lot of nightmares. A lot of companies have lost billions of dollars because models were not fresh, they were not updated. There's bias. There's a lot of things which I'm going to cover. So that's the thing, right? You need to continuously remodel, and you need to manage the code, but you also need to manage the data, right? DevOps is good at managing code, but then in the case of MLOps, you need to manage code and data, right? So I'll talk a little more about that. And again, a lot of organizations have invested a lot of money on DevOps, and they think they can use DevOps to manage AI, but they fail because DevOps doesn't have continuous monitoring, continuous training, model governance, model registry, model versioning, data versioning, data lineage, a lot of things, right? So I'll talk a little more about that. And of course, the last one, in order to take something into production, you need to bring a lot of teams together. And, trust me, in a large organization, bringing them together, even into a meeting, is hard. Forget making them work together to kind of take a model into production. So that's a big challenge. These are the challenges which typically organizations face. And these are the challenges unique to AI. A lot of them understand only after they've spent few years experimenting and burning their hands. And that's where companies like Katonic come in to kind of bring in the best practices, so that you don't do the mistakes of what many others have done, and you can get the value quicker. And the other thing is, like I said, AI requires a lot of things coming together. Data scientists are like today's kids. They're pampered. They are showered with a lot of new tools, right? So there is ChatGPT, which is open source. There's so many transformers open source. There is a open source tool from Facebook. So every day there's an open source tool, and data scientists, and there's a framework, and data scientists want access to that, and they want it immediately, because if it takes 3 months to get access to that, and data scientists also need compute, right? Because there are various models, there are various techniques. You need GPU-based compute, you need CPU-based compute. Sometimes you need large clusters, you need distributed compute like Dask, Ray, and typically they're dependent on IT, right? And they lose a lot. IT unknowingly becomes a bottleneck. Whereas And again, because this is a lot of open source frameworks, IT and procurement, for them, it's a nightmare because they're more secure. They're used to working in a process oriented, and data scientists are more working in a different way. So they always end up, not working together, right? And that's where the solution is MLOps, right? Machine learning operations. And the way you have IT, I'm sure, look, be it a bank, be it a IT store, be it Best and Less, be it Blackwoods, or be it a bank, right? Every organization has an IT team. You cannot imagine an organization without an IT team, right? But in 5 years, I can tell you that every organization will have an AI team, or you can call it machine learning team, right? And the way you have IT teams, you're going to have machine learning teams, and they need to operate. They need tools, and there'll be processes, and that's what MLOps does, right? So MLOps is essentially machine learning operations. And what DevOps did to the code in 2001, 2002, where code was managed with CI/CD, which is continuous integration, continuous development, which is nothing but when you make a change to a piece of code, you don't want to be waiting for 3 months for a release. You're able to test everything. So if you're Amazon, and if you want to change a particular label from yellow to green, you shouldn't be waiting for 3 months. You should be able to do it then and there, right? That's what DevOps enabled. And MLOps is an extension of DevOps, which will enable continuous development of AI. So this is how an end-to-end AI machinery will look like for an organization, where you're continuously ideating with business, working with them to identify the business opportunity. Then there is a committee which will kind of prioritize, because there's always a limited data science team. And then you identify the opportunity, or identify the business use case which you want to experiment. You hand it over to the data scientist. They do an experiment. You fail fast, but more importantly, if you're successful in an experiment, see, failing fast is fine, but if you're successful in an experiment, how do you put that into production and get value out of it fast, right? That's what MLOps does. And then you continuously maintain and monitor the model, and all this is done by teams of 4 or 5 different kinds who work together, right? So that's machine learning operations. And this is what Katonic does. So we live on Kubernetes. What it means is that we are able to install on any infrastructure. We're not bound by any infrastructure. We install, we have installations on Google, Azure, on-prem, all AWS, and we are not opinionated, right? Because data scientists hate to change the way they work, right? They like to work on Jupyter notebooks, or R or MATLAB, or they have the favorite tool of their choice. So we are agnostic to infrastructure. We are agnostic to IDE environment, right? We provide Jupyter, R, MATLAB, IDE environment of their choice. We provide library of their choice. So Python, PyTorch, TensorFlow out of the box, right? And we let them spin, compute in a self-service manner. And so essentially, the platform lets data scientists do their part, and then we take that into production. So with that, I'll go to the demo. I'll again take a pause. Lamont, any questions, any feedback so far, or yeah?
Yeah, I think, well, just maybe some quick ones, but maybe you'll go over it. I think you did raise the point of the challenges that might arise when you operationalize AI and or MLOps. Obviously, you're providing, one solution, but typically, how does one mitigate some of these challenges, or what? And you did allude to best practices for how to manage and deploy ML models in production environments. But just to give our class who may not be very aware of this, like, what is the traditional view of this?
Yeah, good point. So before the demo, so although the slide says demo, what I'm going to do is I'm going to run through the MLOps process, right? And this is from Google published a white paper in August, and that's kind of an industry standard process which everyone is following. So what I'm going to do is next 15 minutes, before I actually show you the real demo, I'm going to talk about the process and how do you bring everything together, right? Because so far I talked about the challenges. I said MLOps is the silver bullet which will kind of solve all the problems. So I want to talk about the MLOps process. So good timing, good right question at the right time, Lamont. So if you're okay, I'll move ahead. Yeah.
Sure.
Fantastic. So in order for me to explain MLOps process, didn't want to kind of talk in isolation. So we've taken this use case, we call it customer churn, right? Now, it could be, so when we say customer churn, it could be a customer who has a bank account with you. It could be a customer who has a loan with you, or it could be a customer who has in the case of telecom, right? So in the end, customer churn is customer churn, right? The way it works is very similar. The various industries can be different, but for today's demonstration perspective, we're taking an imaginary bank called Data Bank. It's a very 50-year-old bank, millions of customers, both in retail banking, business banking, in home loan. But then what's happened is they've invested millions of dollars in the last 5-10 years, bringing all the data in one place. They have data warehouses, big data. They have BI tools, all kinds of tools, Tableau, Power BI, name it. But then the head of analytics is really not happy. He's under a lot of pressure, and he's under pressure because a lot of customers are leaving the bank, right? And they're leaving, left and right. And the problem is the descriptive analytics, the investments they've made can only say what has happened. It doesn't say why they're leaving, right? That's where they're struggling. And the goal, in the next 1 hour, I'm going to explain how do you actually, use AI to solve this problem in a step-by-step manner, right? So that's the intent. So now the bank has decided to use AI to predict which customer is most likely to leave before they leave. And then the next best action could be to have a call center person call, or maybe roll out an offer, or take corrective actions. Now, what you do with that, I'm not going to go into that. I'm going to talk about why it's happening, right? How can you predict that a particular customer will churn, and how do you do that using AI, right? So firstly, look, everything should start with a business problem. A lot of organizations get excited about AI. They bring in data scientists. They kind of start working on it. Unless you have a business problem you're solving, and unless you kind of working very closely with the business, and if you've not identified the problem statement, and if you've not agreed with business on the outcome they're expecting, and the accuracy, because see, in data science mind, 60% accuracy, the model might be horrible, but for a business, if the probability of something happening, if it increases by few basis points, also business is very happy. So it's very important to work with business, and most of the organizations who do not align their AI effort with business, they eventually end up failing, right? So this is very important. This is a framework which we kind of ask our customers to kind of use it, where you're articulating what you're trying to do, what's the success criteria. And once you've done that, the second step is to identify the data sources, because in the end, you need data, and the data is in an organization not really stored for AI. It is stored for the business application. So you have Salesforce, so the Salesforce data. You have you have your data warehouse, so all your data is sitting there. So there's a marketing HubSpot, your data is in HubSpot. So data is siloed, and it is actually designed to be stored for that particular business application. So we need to identify the right sources, and we need to try and bring that data into one place. So that's the thing. So the first step of AI is to define the business problem, identify a couple of data scientists. Now there are a lot of companies who claim a citizen data scientist can come and drag and drop and build a model. Yes, you can use auto ML as well as part of this step. It could be either a manual step or it could be an auto ML, but everything starts with an experimentation, right? So typically, look, nobody really builds an algorithm anymore. So, if I demystify model building, typically what data scientists are doing is they're taking the data, understanding the data, cleaning the data, creating features, right? And I'll talk about what features mean. And then taking those list of features and running them against a particular algorithm, which is already available. And there are various kinds of algorithms available, right? There's PyTorch, TensorFlow, Scikit-learn, depending on the use case. So it's a trial and error where you create a feature, run it against an algorithm, create a feature, run it against another algorithm, and then compare all of these runs and then identify the best algorithm which is performing on that particular data, and that becomes your model, right? So in the case of customer churn, you probably need to get data from your CRM system, maybe data from your warehouse. I'll talk about the data structure, and then the data scientist is actually doing this, right? Now, before I get into that, just want to talk about feature engineering, right? Feature engineering is a word which you'll hear in AI world time and again. Just wanted to spend a few minutes here. So essentially, look, if you see, AI is not, what AI is doing is mimicking human intelligence. Now, if you're a salesperson who's responsible for selling an apartment in Milson Point, right? You know that if the entire family came to view the apartment, the likelihood of them renting or buying that is very high, right? Or if the entire family came on a weekday, right, the likelihood is very high, because if somebody is taken half an hour out of their weekday. So these are nothing but signals, right? So essentially, features are nothing but signals which influence a decision. Like in the case of customer churn, so what are we trying to do? We are trying to predict which customer might churn, right? And it's a probability. So the AI will tell you this customer might churn. The probability of this customer churning is very high, and the way you do that is by training various algorithms and finding the best model. And the training happens using the data, but with something called features. Now, those features can be, different kind of features. They could be technical features and business domain related features. So technical features, data scientists convert them into, encoding and things like that. And then it could be contextual features, like, was it a holiday? Was it a weekday? Because no database really stores that as a weekday or a holiday. It's mostly a date, right? So you need to, so like in the case of customer, or in the case of the real estate example, did the customer come on weekday? That's a feature, right? So what was the weather looking like? So there are various features or signals which data scientists identify or create using your data, right? This is transformation. In the end, the features are created using transformation. There's a piece of code which is written which processes the data to create that feature, and then you take those features and then you train the various algorithms and you get the best model, right? That's a bit about feature engineering. Now, going back to our end-to-end process, the first steps always start with data identification. Identify the data, take a dump of the data, put it in one place, give data scientists an environment where they can code, right? Because this requires coding, right? Now, organizations use laptops. There are companies using cloud. If you're using MLOps platform like Katonic, at a click of a button, you can spin environment with algorithm of your choice, with GPU, CPU size of your choice. And once you've done that, you will then do a lot of training, right? So you will create features, train an algorithm, create features, train algorithm. You need to track experiments. So there are a lot of tools available for experiment tracking, which you can use, and ultimately you find a model which is working the best. Now, this is experimentation. This is the easy part, because in this, it requires offline data. You need few data scientists, few weeks, few months of effort, and boom, you have the best performing model. You show it to business is excited, but then the real challenge is, how do you take this model into production, right? And that's where MLOps comes in. So the next step, once you identified the features and identified the best algorithm, the next step is to ensure that all the transformation or all the code which you've written to create those features, you take that and then you put it in a source code repository, and so that you're doing versioning, right? You don't lose what has happened. And this is where a lot of MLOps tools come in, where you are now able to convert that particular piece of code into a scalable pipeline, right? Now, why do we need scalable pipeline? Because see, when you're training on small data, right? But when you're moving into production, you are actually, doing the same thing on a large data. It could be, terabytes of data. And also you want to automate. Jupyter notebooks don't really scale, right? What you want to do is you want to automate these pipelines. And I'll talk a little more about why do you need this pipeline later. But for now, let's just stop at that these notebooks have to be converted into pipeline, which is typically done by a machine learning engineer. But the thing now is, the data which you brought offline, you need to ensure that you need to connect to that data. Now, you can either do an ETL and bring all the data in a warehouse, right, which can be a time-consuming and expensive process. Or most of the organizations now, what they do is they use the MLOps platform like Katonic to kind of connect to the data sources and build a connector which is constantly bringing the data. And then you connect that to this pipeline, and you recreate this model which the data scientist created, show it to the business. And now, model has to be consumed, right? Now, there are different ways of consuming this model, but you need to version the model, just like, code versioning, because when you have another model, every time model deteriorates, you need to create a new model. And if you want to roll back to the old model, or if you get sued after 6 months saying on a so-and-so date, you gave this inference, so you should have the ability to go back and recreate that particular model. And that's why model registry comes into the picture. And now what you do is you take this model and you convert that model into a scalable API in Katonic, and that's on Kubernetes serverless API, which can cater to millions and millions of records, right? Because the model needs to be scalable, right? If like we are working with a large app company, they have millions of calls to that app, to the API, right? So you should be able to cater to that kind of traffic. So you can consume the model through an API, or you can consume a model through a web app, right? So you can build AI applications which can consume the model. I'll show you an example of that. Or in case of BI, you already have made investments in BI. So in this case, Databank has made investments in, say, Tableau. You can have batch processes which can now take the data, run it against the model, and in addition to the descriptive, you'll have another row saying what's the probability of the customer quitting. So it becomes predictive, and then eventually you can make it prescriptive as well, right? So this is this is what the best practices are. But like I said, once you put a model in production, you can't just put it in there and then forget about it, right? You need to continuously monitor the model, because like I said, the model deteriorates. And monitoring, there is two kinds of monitoring. One is monitoring from a performance perspective, right? One is availability, where you're looking at what's the CPU consumption, how many API calls, what's the latency, right? And Katonic provides out of the box matrices for that. And the other one is performance, right? Do you want to see how accurate the accuracy is? You probably want to monitor the bias. You want to monitor various. So there's so many different matrices data scientists and business would like to monitor. And every time you see the monitoring, every time you're monitoring and you see the model is deteriorating, you need to actually recreate a new model with the latest data, because it could be after a month, it could be after a week, depending on the use case, it could be after 6 months. And then by then, if your data scientist is left, right, you cannot be dependent on the data. That's why we convert that particular piece of code into an automated pipeline, so that every time the model deteriorates, we trigger that pipeline runs, and then a new version of the model is created. It is put in the registry, you do the A/B testing, and then you can put that into production. Or there are certain customers who just trigger the pipeline creates a new model which is bumped into production straight away, because they believe in the process, right? So this is MLOps, I would say level 2, right? Where you are trying to and this is the best practices which you get from companies like Google and Uber, and this is the right way to do things, right? So I'll take a pause before I jump into level 3, which might become a little technical, but I'll keep it non-technical. I'll just take a pause here again. Lamont, any questions from your side or comment on the process?
No, thanks for giving the rough outline for the students here. So I think we can continue. I think just to focus, if we can, just from a high level, from our managers and leaders and executives, how would they approach this problem of churn, which, just going back to the original problem statement, but this is good context to at least hopefully introduce them to the AI model lifecycle.
Yep. So we'll go through a notebook where we will take real data and we'll run you through how it is done in practice.
Right.
But it's important to understand, once the model is built, what to do with the model, right?
Right.
And how do you bring all this thing together so that you can get the value? And this is some of the best practices from the industry. And Katonic comes in built with all these practices, with role-based access and with proper handoffs and governance in place, right? So that's level 2. There's more to it. And if it gets too complicated, don't worry. Not many organizations will reach there in the next 3-4 years, but you have to future-proof yourself, right? So let's say you have a very large organization, data bank, right? There's a lot of business units, right? There's a lot of data scientists. There's a lot of teams working on it. So typically what happens is, in a bank, your data remains the same, right? You have your core banking, you have your CRM, but then with different business units, typically a lot of these data scientists, and like I said, every AI program is all about feature engineering, right? You take the data. So typically what happens is, a lot of these organizations have a lot of, unless they have a centralized data analyst team, which is very rare, right? So there's different business units, there's a lot of separate teams working on AI, and they end up creating features, which is good. But then many a times they're trying to create the same features again and again. There's no reuse of features. There's such a waste of energy, right? Because you probably want to reuse the features which your data scientist in another department or your senior or your is already created. So that's one big problem as you start having the bigger and bigger team, right? And the second problem which you face is, every time you create a model, right, the model has features, right? There's something called featureization code. Now, if you want to consume the model and if you want to call that API, you need to ensure that your featureization code on the model is same as the featureization code which the app is calling from, right? It needs to be equivalent. Otherwise, you end up having something called offline-online skew, right? And becomes very difficult. So if you're refreshing your model every month, you can't go and change your every app, right? So that becomes a challenge. And that's where a concept called feature store comes in. Katonic comes with an inbuilt feature store, but we also integrate with other feature stores like Hopsworks, Tecton, right? There's a lot of feature stores. So essentially what feature store does is it's a repository where you take all the features and store them so that you are able to reuse the features, right? And also because feature store stores all the features, it eliminates the need. So most of the organizations have now decoupled the training and the inference pipeline from feature engineering. So you have a pipeline, so you have ETL, which brings all the data into a warehouse. Then you have a feature engineering pipeline, which takes the data from data warehouse, augments that with other data, could be external systems, and creates all the features and puts in the feature store. So that becomes your feature engineering pipeline. And then you have your data scientists then working on the feature store to train models and get inference and everything. But the advantage of that is you can now eliminate the featureization at the end, which means that every time you refresh a model, you don't have to go change anything on the consumption side, right? Which saves a lot of time and money. And if I kind of bring back everything together, this is the nirvana state. This is the MLOps level 3 maturity as per Google. This is the nirvana state where you have all the data coming in. You do feature engineering to do feature and write it into a feature store. Then you have experimentation happening. And then once you've done the experimentation, you have pipelines to do the experiment. And then, you have the other pipeline here is the automated pipeline for retraining. And, there's continuous monitoring here. And then you just trigger it, right? So if it's essentially a summary of all the things which I said. If it's overwhelming, no problem, don't worry. I think as long as you understand level 2, you're okay, because this is when you have hundreds and thousands of model, and then teams of hundreds of data scientists working on many models together. That's when this problem comes in. But the reason I wanted to mention is that you need to understand and you need to future-proof yourself, and Katonic provides a feature store and the capability to create feature engineering pipelines and things like that. So with that, I'll stop, and then I'll now go to a demo where we'll run through the actual notebook step by step on how you can take data, convert that into features, and things like that. Yeah.
Great.
Fantastic. Let me just stop sharing. So we started at 11, right? So we still have 45 minutes, right? Yeah. Okay. Just give me a second. Okay. Yep. So let me just share the screen. Okay, let me know when you're able to see the platform. Yeah. Okay, great. So see, like I said, the first step in any use case, right? So in the case of customer churn, the first step is to identify the data, right? And once you identify the data, you probably, for the experimentation, you want to dump the data, convert that, dump it, right? Now, you need a place where you can store all the data. So in the context of Katonic, we have a place called File Manager, where you can dump all your data, right? And then here we have a private bucket, public bucket. So if you want to have data where you want to restrict to yourself or a data to share across an organization, you can do that. And here, you can bring in the data. You can then, version the data and things like that. So this is where you bring in all your data. And like I said, data scientists need an ID environment, right? Integrated development environment for the coding. Now you can use your laptop, right? But then, just want to show how easy it is on a platform like Katonic, where you can just go spin yourself a ID environment. Now, like I said, we're not opinionated. We cater to all the notebooks. You can add more. We can add ID environment of your choice. So we have Jupyter Lab, Jupyter, Visual Studio, RStudio. We have Katonic Studio, which is actually a drag and drop capability where you can drag and drop build models and data engineering pipe. So in this case, the data scientist will come and give it a name, and then depending on the use case, now it could be a TensorFlow, it could be PyTorch. So imagine the amount of time you save, because we're giving you a Jupyter notebook with PyTorch pre-installed, and then you select how big you want your machine to be, and then boom, in 2 minutes, you have an infrastructure where you can actually go and start coding, right? And it is not opinionated. What it means is that the Jupyter notebook, which you have been using on the laptop, now it's available on the cloud. And we give you all the dependencies installed with all the CPUs and GPUs, so that you can, so within 5 minutes you can get the infrastructure of your choice. You can start them, stop them, you can delete them to save cost, right? So now data scientists got two things, right? They got they got the data in here, and then they got the ID environment to start coding. So if you click here, so this is Jupyter notebook where you start coding. And what I'll do is I will take one of the notebook which we offer as part of the platform, as part of the accelerator, where we give the notebook as a template, because in 2023, if you're starting something from blank screen, something wrong with you. You always want to start and build on something which has already been done. And I can tell you that any problem you can think of, somebody's already solved. You just need to modify that for your particular thing. So in the case of customer churn, so we offer over 200 pre-built use cases. So in the case of customer churn, you have the bank customer churn. We talk about what it does. I think I went through in detail. Let's open the notebook, right? So you can, the notebook is in GitHub. So you can go to the Jupyter notebook, which you spun a few minutes back on the platform, and then you can just go and press few commands, and you can bring that particular code here. But what I'll do is I'll run through this code, and Meghana is here on standby to answer any technical questions. I will run through more from what's happening in the notebook, right? If I can understand, I'm sure you can. And if there's any technical details which is required, I will ask Meghana to jump in. So this is a notebook. So like I said, we offer 200 plus pre-built use cases. The good thing is you don't have to scout, and this is from open source and working with customers and many other sources. So here it's the introduction of what we're trying to do. We're trying to build a model which will classify if a customer is going to churn or not. And we also want to have a model which can attach a probability, right? We want to know if the customer is churning with an 80% probability or 90% probability, so that the business can then define a particular criteria, right? So now like I said, feature engineering is a trial and error method where you take the data, convert that into features. So what we have done is, for each of the use cases which we have identified and providing as part of the accelerator, we provide pre-built, or at least the features which we suggest the data scientist should look at for this particular use case. But like I said, it is more of a template. Depending on your context and your data, you might want to create additional features or drop some of them because they're not making sense. But this is just to help you understand. So in this notebook, we are suggesting that if you want to train a particular model, these are the features you bring in. And essentially, look, AI 101, when you're training a model, let's say, for example, we are training a model to essentially predict if a particular X-ray has a breast cancer or not, right? Now, how do you do that? You essentially take 1 million X-rays and show it to a model and say, look, these are good ones. And then you take 50 or 40,000, whatever is your sample data, the X-rays where there is breast cancer identified by doctors, and say, hey, look, this is where there is breast cancer. Now, AI creates a pattern, and next time when you give an X-ray, it predicts what's the probability of that particular X-ray having breast cancer, right? So that's a simple example. But in the case of customer churn, if you're trying to build a model to predict if the customer will churn, you need to have data of customers who have churned and who have not churned, and you need to have a flag, and that's what this flag does, right? It essentially tells the model these are the customers who have left and these are the customers who have not left, so that the AI can start understanding the pattern of people who leave, so that when it sees a similar pattern, and those could be hundreds of patterns, right? It tells you that this customer might quit, and you can actually create this. You can integrate this into your processes, so that you can know every day which customer is most likely to churn, right? So these are the features. I'll take a pause. Lamont, any question? Do you think I'm moving in the right direction? Any feedback so far?
Yeah, I think this is fine. I think if we can get to the part where the students might be able to understand the data set a little bit better, but I think you're about to get there.
Yeah, I'm going to go through that. Yeah. So the first thing, like I said, is data preparation. Right now, once you get the data, it's a trial and error. So data scientists have to understand the data, and this is again code first. There is no code, low code way of doing it as well. But today's my focus is more on code first. So essentially, your data scientist is then reading the data framework to understand what kind of data there is, right? So in this case, and then let me just go through it. Or maybe I'll do one thing. I'll hand it over to Meghana. She's probably the best person to run from here. Meghana, will you be able to kind of go through the notebook? I think we have about half an hour to
Yeah,
help
sure.
understand. Yeah. Let me pause here. Let's let the experts do the right thing.
Yeah, I'll be sharing my screen. Let me know if you can see the screen.
Yeah.
Okay. So here, as Prem said, tell the features that we are going to create. That would be the plan that these features are required to find out if the customer will churn or not, because this will give you a better understanding to the model. So firstly, we'll go read some data, get that data. You can read it from file manager, which Prem has showed you, or if you have sitting that data in AWS, Azure, S3 bucket, anywhere, you can also connect through that. We have connectors for that as well. And then you can read data from there. Now, once data is read, like we are just trying to find out what kind of null values it has. Like, is there any data cleaning that is required, which is missing in the data and all? Like, we are trying to find out the null values and all here in the data. And then the ID columns, like customer ID, with which we are not going to train the model on, and row numbers and all kind of stuff which you don't want to train the model on, that kind of columns you can drop off. And then we are checking if every column is of right data type or not, because model will be trained only on numbers that should be integer, floats, or doubles. It can't be any date, object, string, and all that has to be converted again. So we are trying to find out if we have any kind of that columns. Here we can see geography, gender are of object type. So we're now trying to, will be next in the next process, in the data cleaning process, will be changing that. We'll be doing encoding for that kind of data. So now we got to know what is the missing values we have, what are the type mismatch we have for the data, and then the next thing that we want to see is like how data is distributed, if it is uniformly distributed or not, because data can be inclined to one side. If suppose every data you have is custom churn data, out of 100 records, only 2 records are not churned, and out of 100 are churned, that doesn't mean make any sense for the model to be trained on, because it will be biased. So we need to check on how data is, how many we have for churn, how many we have don't have for churn. So that distribution should be uniform, or at least it should be 20/80 or 36/70 kind of. So here we can see that it is a pretty much good amount of data we have. And then other feature, participation, how it is that other features, how they are related with the output variable. That means the customer will churn or not is a feature here. And the other features like geography, gender, how they are related with that output variable, we are trying to check so that we can change its distribution if we want. Here you can see geography. In geography, France is participating more. That means we have a lot of data from this region. And that way you can find out, and if you want only for one country, train it separately, you can decide on that. For that, you do this kind of exploratory analysis. And here again, you do a box plot to find out outliers if you have any. You can see that in this data, there are some points sitting here in this data, there are some points sitting here. That means like every data point is only from range 40 to 50 here, but only some data points are here. If you find there are many outliers, then you need to find the process to eliminate outliers or treat them on. So to find out if we have any outliers, we are doing this exploratory analysis. So now we have gone through all the data and we got to know what is the issue with the data, what kind of cleaning techniques that we need to follow on. We got to know that by doing all exploratory analysis and printing all the information about the data, meta about the data when you see. Now, once you have got all the information about the data, it is time you clean the data and create features on. So now here we are, as I've said, we already find out some features which are important to train the model. Now, one of them is balance salary ratio. We feel like balance they have in their account and salary they have, like, we find this feature would be better suitable. That kind of some features, tenure and all, we felt would be better to be used to train the model. So we are creating that kind of features here. After creating that features, now preparing data to fit for the model. That is like, we, out of all complete data which is available, we are segregating data into train and test. That is because, like, we need some data for the model to be trained, and once the model is trained, we want to validate our model if it is right or not. So for that, we need to segregate some amount of data to the test data. So that we have done here. And then after doing that, then we are doing like some kind of vectorization in data, standardization, because some values like salary is in lakhs, millions, and all. But like, if you see, the age would be numbers ranging from 30 to 60. So that do have different scales. You bring that same scale so that model doesn't give higher weightage to the salary. That kind of standardization techniques we also use, that we have performed here. Once that all is done and data is prepared and ready to fit the models, then we come here and do the model fitting. We have tried here different models, logistic regression, SVM and all. Now we are doing model training here and logging the models as well. And also we are trying to hyperparameter tuning, doing hyperparameter. That means every model will have some fixed parameters. Parameter values can be changed. So you tune on different values. You can see here maximum iterations 300 and 500 are we tuning and finding out which would be the better parameter. That way you tune the parameters, and then you get the best parameters and the best model. Once you run this one, these are all the logs when the model is trained for every record, how it is behaving. You can see that. And then in the end, the best model that we got was logistic regression. Logistic regression, you can see we have different model parameters here as well. The SVM, random forest, we tried and all, XGBoost. So out of all that models, we are trying to print for every model what is the performance metrics. You can see for the classification report that we got here was about 83% for one of the model and 87% accurate for other model, 86% accurate for the other model. So out of all these models, we are trying to find out which one would be the better model, better curve that can be fit. And that better model logistic regression, which we have obtained, that has 88% of accuracy, we are using that for the prediction. Now we'll be deploying that model. We can show you that in the platform, how we deploy the best model. And then that model we'll be using for the inference. So in the conclusion, it obtains that around 86% of accuracy model we are getting. That is the logistic regression model. Prem, do you want me to continue with the deployment?
I'll take over from here. So, Lamont, any question? I know, we went through quickly, but any questions? Because typically data scientists kind of know what's happening here, right?
Yeah, I was going to say, no, this is pretty standard for a data scientist audience. For our managers and leaders, I think, and executives, it's probably a little bit too technical at this point, but I think at least you did show some of the visualizations. So I think it's pretty clear, like, if you do understand the language and the syntax, then it should follow what, how they would actually use this interface. So what I think would be useful to just maybe step back a moment and say, let's say, you know, they're interfacing with a data scientist. So at this point, you know, where would they go? You know, so I think, you know, we've built some very simple models together. And so this is the level of detail that we've, you know, shown them so far. So where would they go after this in terms of, you know, this is just the model building piece, and so now how would you go to the next step?
That's what I'm going to take over. So now this was the experiment part. So let me present the screen again. Let me know when you're able to screen. Thanks, Meghana. So so if I let me know when you're able to see the screen. Yep. Are you guys able to see?
Yes.
So now what Meghana showed is how do you take the offline data, right? So we took the data, we put it in the file manager. It was in a CSV file. We cleaned it, transformed it, and finally, you know, we trained a lot of models, and then we finally got the final model, right? So now a few things which I want to talk about before I jump into what happens next, right? So let me go back to the platform. Now, when you're actually doing experimentation, right, many a times these experimentations happen over a period of many days and many weeks, and it is humanly impossible for anyone to remember all these experiments. So this is where you know, Katonic and many others provide a tool where every time you experiment, you log that experiment. And you know, Katonic, if you know, comes with an SDK. So if I click here and go to the SDK, we offer a simple one line which you need to add into your Jupyter notebook let me go to the experimentation. So all you have to do is just add one line into your code to create an experiment, and then start logging your experiment, right? Now, the advantage of doing that is if I go to our experimentation section, now you are able to group all these experiments per project, right? Now, in the case of customer churn, I don't have it here because we haven't logged, but let's say loan prediction, right? So when you click here, okay, so when you click here, so there's someone who's logged a lot of, so you can see forest classifier, decision tree, there's a lot of logs. And then if you click here, you can see the various runs, you can see the parameters. And if I go back, you'll be able to now go compare these experiments, right? So the good thing about using a platform like Katonic is that you're able to log your experiments, and then you can go see all your experiments grouped by particular project or a particular business use case. And then now you're able to go and compare all these experiments for accuracy, RUC, whatever F1 score, whatever score you're after, the precision score, right? And now you're able to compare all of these experiments, and then you know, visually, and you're able to see which is the best experiment which you are happy with and you want to move into production. Yeah. So any question, Lamont? This is essentially you know, a place where all the experiments are logged, and you compare all of them and you identify which is the best experiment based on the metrics which you want to use, right? Various use cases have various matrices. Depending on your use case, you might want F1, you might want precision score, and things like that.
Yeah, no, thanks. No, yeah, well, yeah, I mean, maybe you just continue for a little bit and then we'll see.
So in this case, so let's say you know, you ran a lot of experiments, right? Let me just go back, and then finally, you know, you feel that the experiment, the random forest, this particular experiment, right? If I click here, was the best experiment, right? You're very happy with this experiment. You're able to see these matrices. The accuracy is 96.5%, right? And you're extremely happy, and you want to move into the next. You want to move this into production, right? So what Katonic does is the process of moving a particular model into production is very easy. All you have to do is register this model. So click here, give the model a name, right? So let's call it UNSW use case, right? And then press a button. This is bank loan. So what we did was, so what data scientist typically does is they do a lot of experiment, find the best top 2 or 3 models which they want to move into production, register them. And you can see all the models which have been registered in model registry, right? So I just gave bank loan, right? So you can see that bank loan has been registered, and you can click here, you can see all the details. And this is where the handoffs from the data scientist happen to machine learning engineer. Now, again, look, depending on the organization, they could be the same person who's acting as data scientist and machine learning engineer. But typically, data scientists are good at understanding a problem, building a model, and having them convert that into scalable pipeline is not fair, because you probably let them go do the next experiment, right? So once the model is registered, right? So in this case, I registered this model. You get in, you see the model, you kind of perform certain test, and you move that to staging, perform certain test, and then once you're happy and you feel that this model needs to be moved into production, all you have to do is tag this model to be moved into production. Let me just tag it. So what it means is that the model was built, it was recommended by the data scientist. You can have a QA team who came in, who created a staging environment, tested it, showed it to the customer. And the good thing about Katonic is, when let me go here into the accelerator again. So when you're testing, right, and when you're with businesses don't really understand the code, right? So what we offer is, as part of each use case, we provide an app which can be used to test the model, right? You can use it for test the model. You are essentially using for interacting. So you can, the business can start interacting the features and then predict, and then this is where you are actually testing the model. And once you feel that that particular model is the one which is good, and you want to move into production, you tag that as production. So if I go to bank loan, I have version 1 of the model, which has been tagged into production, and it's time to deploy this in production. Yeah. And how do you deploy? So the deployment on platforms like Katonic is very easy.
And then just really briefly before you deploy, so
Yeah.
can you help the audience understand, so from this exercise, what did the AI model predict, or what was the future of churn?
Yes. Let me do one thing. Let me bring up the app. Yeah, here is the app, right? So if you see the notebook which Meghana ran through, I'll just go back to the notebook. Using the raw data from various sources, essentially we created about 10 to 12 features, right, to train them. Now, once the model is deployed and finally, you identify the best algorithm or the best model, you need to now, pass these features, right? So if I go here, you can see the credit score of the customer. Right. So let's say you want to know so I have a customer who has high credit score. I have a customer who's from Spain. The customer is a female. The age is this, and the customer has been, the person has been the customer of the bank from so many months. This is the balance. This is the number of products the customer has actually, bought or interact with. Has with the bank. Does it, do they have a credit card? That was a feature. Is the customer active? Of course, this is active. And what's the estimated salary? So when you do a prediction, now based on these inputs, the model is now able to predicting what is the probability of this customer churning, right? Now, what if it was a male, right? So the probability of somebody in Spain churning was 66%. Now, if I change it to male, it's probably the same. So probably gender doesn't matter, right? So this is a way of interacting on the model. So we built this app and this is again built using Python in the environment which we provided. And Katonic lets you actually deploy these apps as well, right? So now you're the business, instead of looking at the code and the model, they are actually interacting with this to test and give a thumbs up. And once the thumbs up is given, you can then tag that it needs to be moved into production. And then the next process of deploying that and converting that into a scalable API starts.
So you were able to show, just for the audience here and to our class, so you were able to show here on an individual basis, you can come up with some probability of whether or not a customer will churn based on those characteristics. I think probably a question that they'll have is at a very high level. So you've just noted that gender may not play a role in prediction. So to help, so we run a data analytics simulation with Harvard, and they have all these different knobs and levers. Is there something here that you can show them about how you've identified certain parameters or certain variables here in their level of how well they predict churn?
So yeah, so it's called feature scoring, right? So what features contribute to the, so usually it is part of the notebook. Once the model is created, you can, have the, which features are contributing. Meghana.
It's feature selection process that we do. We see how the output variables are, which input variables are highly correlated with the output variable. So
Right.
whatever the features are highly correlated, we take them out and we score them higher, and we take them out and train the model on that only. Because too many features can spoil the training process, because something which is very oppositely correlated with the output variable can degrade the performance of the model. So only
Right.
which are very correlated, we take them. So the features that are shown in the app are like highly correlated features that we have taken.
And also,
Yeah.
we can see once the model is deployed, we can actually show which features are contributing more, right? So in this case, changing the sex didn't matter, right? But then, so it can be done. So there is a way to do that, and we have an open source component called Explain It, which exactly does that, which I'll talk about once we have deployed it. Because when you're deploying as part of the monitoring, you want to do the accuracy and all that. So I'll probably come back to that Lamont, in a little more detail.
Sure.
Yeah. So now, what essentially we've done is we have created a model. We have, created the features, tested them on various algorithms, find the best model, registered the model. We've tagged that for putting in production. And we've also created an app. And before I go into model deployment, I'll just go to the app deployment. So Katonic, you can deploy app using Streamlit Dash. So the one I showed you was a Streamlit. So all you need to do is essentially write in Python. Again, the use case I showed you, that particular piece of code is provided as part of the platform. You can take that, modify it, and then at a click of a button, you are now able to deploy that particular app, which is converted into a web link, which you can share with either public, so you can make it a public, share it with anyone. So if it's a research paper, you want everybody to know what's happening, you can share it, or you can just private, so that it's limited within the organization, right? So now it's time to deploy the model. Model deployment is very easy in Katonic. You give a deployment name, so UNSW loan prediction, and you can deploy models from Katonic model registry. So if you remember, we registered a model, or you can actually deploy models from, so we have partnered with Hugging Face. So Hugging Face has over 30,000 models. So you can just at a click of a button, I'll just spend a few minutes. So you have speech to text, image to text. So if you're looking for a use case where you want to convert audio into text, or if you want to convert image into text, you want to create. So, Hugging Face is a place where you have even the GPT models are there. So you can install and convert that into a scalable API at a click of a button, right? Or you can bring your own custom model. So you can have your own scikit-learn model. But in this case, because we've been using the entire platform, we have Katonic registry. We have the model which we registered here. It's version 1, created on April 11th, which I registered. And the type. So the reason we ask type is because when you're monitoring the model, the matrices for each type varies. So we want to know the type. So in this case, it is classification. And, because this is on serverless and on Kubernetes, so how many pods do you want, right? So depending on the number of calls you want the platform, the API to cater, you probably want to increase the number of pods. So you can decide what's the minimum number of pods. You can decide what's the maximum number of pods. And you create a scalable API and how big you want the machine to be, and click of a button, that particular model is now deployed into the platform. And in few minutes, you'll see that there is a API created, and we'll be able to monitor the usage and the, both the usage, but also the performance of the particular model. So I'll probably wait for 2 minutes for this to happen. While this is happening, I'm going to talk about the thing where we need to convert. So if you remember, we need to now convert that particular piece of code into scalable pipeline, right? So while that model is getting deployed, I'll spend some time on how to convert your piece of code, which Meghana showed you, into a pipeline, so that you're able to schedule these pipelines for both, retraining, right? Essentially. So if I go back, Katonic, if I open the notebook, this is one of the notebook. right, which Meghna showed. So we have a component called Katonic pipeline deployment, where if you click and then you select the particular notebook and press a button, this whole piece of code is converted into a scalable pipeline, right? It is tagged automatically. You can go and change the tag, and it is converted into a piece of scalable pipeline. Let me just and you can actually see all those pipelines here. There's a pipeline section. You can see all of them here. Right. So now in the pipeline section, pipelines is where all the templates are. So once you converted your notebook into a pipeline, this is how it's going to look like. So let me just open one of the pipelines. So this is the pipeline. So you can see this data being loaded. So you can see the logs of the pipeline. You can the pre-processing, feature engineering. We are training multiple models, finding the best model, and then registering that model. Right. So these pipelines now can be run or triggered based on the performance of the model. Right. So you can see all the runs here. So here in this case, there's a pipeline which is run. Okay, this is just a test pipeline. Let me just go to. Yeah, so you can see the pipelines have run. You can see all the logs. You can schedule them. So essentially, if you remember, if I go back to this, we converted. I showed you how to convert this piece into a pipeline, right? You can then every time you continuously monitor the model, and every time you see that the model is deteriorating, you can just all you have to do is just rerun this pipeline, right? So your model is deteriorated. You trigger this pipeline, and the way you trigger is either automatically, or you just come here, identify that pipeline, and run it. So when you do that, it automatically creates a new version of the model, and that's registered in the model registry. So if I show you this one here, okay, it has only one version. Let's see here. Yeah, so you can see the version 1 is already in staging. Version 2 is created. Now what you can do is you can go here and promote this to production. And you go back to deploy. Let's see if this is deployed. It's deployed. Now you can go and edit, and then you can change the version. So if I had created a new version here, you'll see another version here, and I'll just go change the version here, select the size, and press a button. So what I did now is without changing the API, right? Because the API is being consumed by a lot of applications, right? We were now able to refresh the model. So we created a new model, put it in the registry, and we registered. Now let me take a pause on that. I'll come back to that. Now that the model is deployed, the model is now converted into an API. This is the API, right? Now you can copy the API, and of course, you want to be secure. You don't want anyone to be calling that API. So you can actually go create tokens, which is nothing but access code, right? So let's say you want to share this with your UNSW developer. So you just go here, you can create the code, you can have an expiry date, you can say, I don't want to expire, the token is created. And now you take the API, take the token, and you give it to a developer, and developer will now be able to integrate that into a mobile app, into a web app, into a business process, or whatever they want to do. And because developers need all the information to do that, and we don't want them to keep coming to you, we provide out of the box documentation in the language of the developers, so that they have everything to call and test the APIs, and so you can authorize. You can test it, and the developer has all the information they need to integrate that, right? Now, from a monitoring perspective, like I said, you can actually monitor the model in for two different things. So one is from an availability perspective, right? So that you can fine tune your infrastructure environment, right? The number of pods. So you can see what's the CPU usage. Is the CPU usage crossing? Should I increase the pods, reduce the pods? Should I increase the size of the infrastructure? This is typically done by an infrastructure team, right? They're looking at all these pods, they're looking at the memory. So this is more around the health of the model, right? It has nothing to do with the accuracy and things like that. But what we also offer is a monitoring. And remember, all this is out of the box, right? You didn't have to do anything. All you had to do was use the notebook to create a model, and then register it, deploy it, and just say what kind of model it is. Unfortunately, this is not running, so you'll not see the data, but you can see what's the latency, the number of requests, and you can see all this is nirvana for data scientists, because now they're able to real-time monitor the number of calls, but also the accuracy, the correlation, FS, all these matrices. And every time you see that the model is deteriorating, all you need to do is go back to Katonic, go to the pipeline, boom, rerun, and then your model, a new version of the model is created, right? So you can delete the model, you can edit the model to kind of, every time you have a new model, you can do that. You can monitor the usage, and then we also have logs to monitor what's happening inside, right? And we also offer explainability. So we have, and I'll share more details. It's an open source component from Katonic, which helps you understand bias, which helps you understand various other matrices. So you can integrate this into your pipeline, and you can get, what features. So in this case, what feature is contributing into what was the, how did the features look like during training, the production, the drift, the data quality, and everything, right? So yeah, so that's the deploy part. I'll take a pause here again, Lamont. So is it kind of making sense? I just tried to bring everything together.
Yeah, no, thank you, Prem and Meghana. So from my point of view, I sort of can follow and see the whole picture, but again, just sort of for audience who may not be as familiar, I think probably one point of confusion is going back to, so you mentioned that the explain it would help us understand the feature selection and sort of, what are the drivers of the models or the variables that contribute to the biggest levers. Can you show us in a very simple way how you would show that, so that from a business point of view, they said, oh, okay, my data scientist has now come up with these different features, and these are the ones. So in the case that we use today, it looked like gender didn't matter, but some others might. How would you rank order those, or how would a manager or leader identify those within this interface?
Yeah. So see, you don't have to necessarily have explain it. So if you have put the in the notebook, if you have written a code which can show you the feature contribution, you can see that in the pipeline. So maybe I'll request Meghana, are you able to show a place where the feature contribution is there? Maybe it's there in one of the use case. Yeah.
Let me just get it up.
So it doesn't have to see, explain it is more advanced, right? If in your,
I can show you explain it if you want. We have it.
Yeah, we can even run through the explain it. No, but I think Lamont's question is more, how do I, once we have trained, I want to know the
contributions. Yes.
Yeah. So, and how do we integrate that, right? So once you have, see, it's a piece of code you write in the notebook, and once you have put that in the notebook, you can actually visualize that here. I'm just trying to see if we have done that, but I don't see it here, but I'm sure, we'll be able to show you one. Yeah.
I mean, if it's not here and it's something that, we can show later, but just to let the students know that there's an easy way to show that contribution.
Yeah, we do have, I can
Yeah, so while you bring up Meghana, what we'll do is we'll just quickly summarize everything, and I'll also show two other capabilities which typically data scientists need. So if I have to summarize the entire discussion, right? The data scientists usually start with experiments. File manager is where you typically keep all your files, which is a offline data, we call it as. It's basically a dump of all the data from the databases. And then workspace is where typically data scientists code in the IDE environment of their choice, right? And Katonic is not opinionated, so we give you any open source IDE environment, and that's where the experimentations happen. And when you're doing experimenting, you log those experiments by adding just one line, and you can see those details in the SDK, and you can look at all your experiments here. They're grouped by projects, and you can compare them, do all sorts of analysis. And once you identify the best experiment, which is your best model, you essentially register that in the model registry. And model registry is a place where you do versioning of the model, but it is also a place where data scientists hand over to the machine learning engineers. So machine learning engineers come in. There are companies who also have, quality assurance department who come in, who look at that particular piece of model, ensure that it's working all right. And this is where you build interactive apps using Streamlit and Dash, and then you deploy them on top of the model so that the business is able to interact. I did show you an example of that. And once the business is happy with the model, you deploy that using Katonic deploy at a click of a button. which is deployed on a scalable machine. And then you can monitor the usage, you get the API, you monitor the performance, and every time the performance deteriorates, you then initiate the run. And before initiating the run, you use Katonic deployment panel to convert that piece of code into a pipeline. And all the pipelines are managed here. And every time the model deteriorates, you just go and run the latest pipeline so that you have a new version registered, which you can then go into deploy and redeploy, right? So this is the end-to-end. So this is automating everything except the experimentation part, because that's very difficult to automate. But if you're using AutoML, maybe in the next session, we can show you how you can use AutoML to experiment and then take the best model from the AutoML to move into production and then create this entire MLOps process.
Right. Thank you. So I think maybe the other key takeaways from here is sort of, I think, at least from what you've showed us here, we've looked at sort of some ways to manage and deploy these machine learning models, and getting them into production environments, and then how a business can use something like this, a tool like this, to ensure continuous model performance monitoring and optimization in this operationalized AI environment. And then you've gone through the key components of an end-to-end machine learning ops process and how they might be implemented. I guess one of the questions that might pop up is, how do you guys ensure the data quality and consistency in this type of MLOps environment? What are some of the key security and compliance considerations, and how would you address these?
So I'll talk about the security and I'll hand it over to Meghana. Maybe we'll spend 2-3 minutes.
Yeah, I'll go through data quality and also as well.
Yeah. So on the security side, see, firstly, Katonic platform or any MLOps platform which you choose needs to be secure, right? So we live on Kubernetes and we've secured using Red Hat Keycloak, and we have many banks using or piloting our solution. So we have all the right certifications in place. We are ISO 27001. And because everything is in Kubernetes, it's very hard for anybody to really crack, right? And on the model side, the models are converted into API, and then you have access key, right? So you exactly know who's accessing those particular models, and then you have monitoring to ensure that you're monitoring. So from that perspective, we are one of the most secure platform with these features. And with that, I'll request Meghana to maybe spend a few minutes on how do we monitor data quality, and also talk about the feature contribution if he's managed to get that piece.
Yeah, I agree. Okay,
yeah,
great.
Go ahead, Meghana. And of course, we will all these notebooks, and we will give access to the team.
Right.
So they'll be able to play around and build this entire thing. And once you build once, you kind of get it end to end, right? So yeah, Meghana, go ahead, please. Yeah.
Thank you. So there are different ways that we can show how feature contribution is. Here you can see this is the one way of showing waterfall plot, it is called as. You can see the red marks are like how higher they contribute, and if it is in negative way or positive way, it differs. So that this graph shows here. This means this value when increases, it is more tend to be to side 1. If this value decreases, it's more tend to be to side 0. Yeah, but it is opposite with this red features. So that way some values increases, their features value increases, the relation with label changes. So that way this feature importance is shown. The higher the bar is, that means it is more important. You can see here, sales officer key has having a bigger bar. That means like this is a higher important feature. That way we can show, or like we can also show with this normal graph plot, you can see account receivable is having the high. This is in the order of like feature importance. Out of this, if you want to choose features which are top 10, top 8, you can choose that top 8 features only. So which are not like highly contributing, we generally eliminate them so that that doesn't mislead the model. In different ways to show as well. We can show the ranking also. And let me, here you can see, we can even show this kind of graphs which shows the model performance. Here you see, like we are trying to find out here, the customer will pay the invoice on time, or like he'll delay that invoice. That is what in this use case we are trying to do. Here you can see out of all 9,273 data, this 2 times. That means when invoice is paid on time, model has predicted he'll pay on time. When invoice has paid late, the model has predicted that it will pay late. That means around 5,000 plus 1,000, like around 7,000 times we are predicting right, and like 2,000 times we are going wrong. So this two we can correct, we can take some measures to decrease this number 1,600 to further less by doing some other techniques in cleaning process and all. With this, we can also know what is the model performance, and we can analyze where we are going wrong and which kind of training process we are going wrong. We can find out and we can take actions on that. That way, this confusion matrices also help. Any
Thank you.
questions on?
Yeah, no, I'm just curious. I mean, I'm not I don't work with banks, but I was just wondering if I mean, maybe this is just a toy example, but I would have expected maybe how many times, because every time you call a bank, I would imagine the bank has some identification of who's calling. They'll ask you, oh, you know, what's your number, what's your account number, and so I would have expected maybe the number of times they've called, the number of times, the duration, or you know, their net promoter score, something like that would have been a very high predictor, but maybe it wasn't collected here, or maybe it wasn't.
We are not showing a number of calls, but like here we showed on the revenue that they lose. That means, suppose if customer doesn't pay, if they follow a model, like here you can see there is around 25 lakhs of amount like they could be able to save.
No, Meghana, I think Lamont's point is that in the features which we have suggested, right? A number of calls the customer has made could have been a feature, right? So that's what. So you're right, Lamont. See, like I said, this is just a template or a starting point.
That's fine.
Not all customers will agree to provide us call data. So yeah, we even request for that most of the time. Yeah, if we can get that, we also consider that, and we even do sentiment analysis as well. We did for one of the customer, like in call, like how he's responding, if it is positive or negative, we take that points as well and train the model on.
Okay.
So see it's not a solution which we offer, right? It's a template, and based on your needs, you can, you know, modify it, right? So it could be number of customers, the sentiment in the email, the sentiment in the call. You can even, there are customers even saying which call center rep did he speak to, because there was an analysis done saying certain reps were pissing people off, right? So customers were quitting. So look, it's a template, right? You have a lot of permutation combination, and that's where you know, modifying this piece of code for that particular bank and that particular data, right? You can't. That's where, you know, you can't have one solution which is fit for all, right? You have to build a solution for that particular customer.
Great. I think you know. Thank you again, Prem and Meghana. Maybe the last question, just in the interest of time. So in Explain It, it looks like, you know, you're trying to understand the data and models. And we talked about model drift. So how do you guys, what are the KPIs that you guys will look for in either the data drift or the target drift? So how do you know that sort of, let's say you're a bank and you're looking at providing loans. And, you know, in America, there's, you know, some well-known examples of how sometimes some of those algorithms might, just because of the data that's collected and because there are inherent human biases, it's sort of historically collected some of this data, and they might unfairly punish certain populations. How do you guys make sure that, or how, you know, from an Explain It point of view, or is there something you can show here that helps a manager or leader understand very quickly, oh, you know, there's some data drift happening here, there's a target drift, or some bias is now reintroduced, or how do you guys look at that?
Okay. Explain It make that easy. You can see here, we create a reference distribution. So for any particular feature that we take in, there is a reference distribution that is fixed. So that means at the time of training, we have seen this kind of distribution. So when even at the time of inference, the data coming should be of same distribution. That means there is no change in data. If the distribution changes, that means there is a change in data. That change in distribution can be seen in different ways. One of that we consider is p-value, standard deviation, and all. So we calculate all that, and then we see if there is change in the standard deviation, if there is change in the p-value and all. And then we, even from the, as you said, like if the values are not understood by some business people, they can look at this graphs and clearly know the difference between the reference distribution and the production distribution. And then they can find it out, like if they see any difference in data distribution, and then go for retraining the model on the new distribution that we got in the data. In the same way that we can do for the target as well, even here for every column that you, every feature that you see, you can compare your values and you can find out your standard deviations here. And it is easy for any non-technical person to find out because these are like just graphs shown.
Right.
So for every graph that we show here, we show it with reference and production so that you can find out if the distribution has changed from at the time of training, from training to production.
Right. And so are there any ethical issues, or I don't know how this is done at banks when you do loan prediction, but presumably you've got ethnicity, race, sex, and gender, whatnot. And so some of those, how do you have, are you able to share of any of that in this demo or this toy?
So Lamont, see, it's bias, right? So this is a first version of Explain It which we have launched. So in the roadmap, we definitely have bias, and how do you fix the bias? So if you have data, we do have bias to see if it's biased against certain, all the aspects you mentioned. And then there is ways to fix those bias using some of the open source components. So that's where, if you remember, I said this is an open source component. It's first version. There's lots we can do together. And that's where we're looking to bring in the responsible AI community in Australia to kind of adopt this piece and then start building, more features into it and then contribute into the platform. Yeah.
Great. And so for the rest of the audience, Prem and Meghana, is there anything you'd like to tell them about, explain it? How do they get involved? How do they get involved in the responsible AI or safe AI movement?
Yeah, so look, Explain It is an open source component. We'll share the link with all of you. It's on GitHub. You can just download. Instructions are in there. Maybe Meghana, you can go to the GitHub. All the instructions are there. We have a contribution guide. So play around with it. We have a roadmap. We are working with Lamont and others to kind of create a team who will start contributing into it. And we want Explain It to become the de facto most popular open source component made in Australia, right? Given to the world to make the world more responsible when it comes to implementing AI. So that's where we're working with UNSW and Lamont. Yeah.
Great. Thank you so much, Prem and Meghana, for your time, for your valuable insights and your expertise, and also sharing with us today how businesses and organizations can operationalize the business value of AI. So again, we'll put some links around for you guys to connect if you guys want. And that'll be it for today. Thank you guys so much and have a great week.